Is going on, everybody? Back for another video. Today I am going to show you how to graph a trig function in ALEKS. And you can see here we're going to graph y equals sine of 2x minus pi over 3. It says express your answers as simplified fractions if necessary, and express points as ordered pairs. So the first thing they want us to do is identify the amplitude, the period, and the phase shift. Alright, so the first thing, the amplitude, that's the sign, that's the number in front of sine, which we can see there's not a number there. It's understood to be a 1. So here for the amplitude we will put 1 and we will hit check, and we get the check mark and we get it right. The period, okay, so the period is remember, now let me see, I'm writing on a Wacom tablet, so this is not going to be as good as it normally is. The period is equal to 2 pi over b. Alright, and you can see the number, well, b, this thing is in the form y equals sine of bx plus c. I mean, you could have bx plus c, bx minus c, you know, whichever one, but b is the number in front of x. So our period is equal to 2 pi over b, which is in this case it's 2, not 1, and so our period would be pi. Well, that's a good looking pi there, isn't it? Alright, so we click in the box over here, and then you can see they have the symbol for pi for us right here. So we click pi and we hit check, and of course we got this correct. And then they want the phase shift. Well, the phase shift, you see this part up here where you're taking the sine of the 2x minus pi over 3. So in order to find the phase shift, I know they give you like c over b or minus c over b, you know, depending on if you have a plus or minus sign here. But basically to find the phase shift, all you need to do is take the 2x minus pi over 3, whatever you're taking the sine or cosine of. This works the same for cosine. You set it equal to 0 and solve for x. So we're going to add pi over 3 to both sides. So we get 2x is equal to pi over 3. And then we need to multiply everything by half. So a half times 2x would give us x equals, and then 1/2 times pi over 3 is going to give us pi over 6. Boy, I'm having a time drawing those pies, aren't I? So here we want to enter in pi over 6, so we're going to hit the fraction symbol, then we're going to do pi, and then down here we'll put a 6 and we will hit check, and we got that right. And then it says graph the function and identify the key points on one full period. To draw the graph, plot all points corresponding to the relative minima, relative maxima, and x-intercepts within one cycle, then click on the graph icon. Alright, so to graph this thing, what I like to do is, you see here what the sine of 2x minus pi over 3. So what I like to do is take whatever you're taking the sine of, okay, and in this case it's 2x minus pi over 3. And what I like to do is I like to put that in between 0 and 2 pi. All right, and then what I want to do is solve for x. So I'm going to add pi over 3 to all three parts. So that's going to give me pi over 3 less than or equal to 2x less than or equal to, and then 2 pi over 1 plus pi over 3. So I'm going to get a common denominator. I'm going to get a common denominator of 3. So that's going to be 6 pi. And then that's going to be pi. So that's going to be 7 pi over 3. So this is going to be 7 pi over 3. And then I'm going to multiply everything times a half to get rid of the 2. So that's going to be pi over 6 less than or equal to x less than or equal to 7 pi over 6. And if you're wondering over there on the screen where it says try one last time, I worked this. I had to go back and redo it. The first time I was over here thinking about showing y'all how to add the fractions and stuff, and when I got there, I got to this part, pi over 3, or 2x is between pi over 3 and 7 pi over 3, and I wasn't even paying attention. I didn't multiply by a half, so I had to go back and erase everything, so we're redoing it. I'll cut all that part out of the video though. But anyway, but this is what we're graphing it over. So we're graphing it from, from pi over 6 to 7 pi over 6. All right. So, and we know the max and min is going to be 1 and -1, because we found earlier that our amplitude was 1. And look, I know you're doing this on online, and you're putting your answer in online. But look, graph the entire thing on paper, everything with your points and all that stuff. Okay. And then transfer your stuff transfer your points and all that to ALEKS. Because when you're taking a test, you're going to have to do it all on paper. So what we need here is we need the midpoint between pi over 6 and 7 pi over 6. So I'm going to show you how to do that on that one. So that's going to be pi over 6 plus 7 pi over 6. And that is going to equal 8 pi over 6. All right, so remember, whenever you're looking for the midpoint between two numbers, just add the numbers, and then we want to take the 8 pi over 6 and divide by 2. Well, the same thing of dividing by 2 is multiplying by a half. And so you see the 2 cancels, the 8 cancels, and this is going to give us 4 pi over 6, which is equal to 2 pi over 3. And remember, ALEKS tells you to simplify your fractions, so we've got to make sure we do that. All right, and then we need the midpoint between pi over 6 and 2 pi over 3. We'll go ahead and work this one out too, and then we won't do that anymore. All right, so I'm going to get a common denominator of 6, and so that's going to be pi, and that's going to be 4 pi. All right, and so this is going to give me 5 pi over 6, and then I've got to take the 5 pi over 6 times a half, and that's going to give me 5 pi over 12. And so this would be 5 pi over 12. And then I need the midpoint between 2 pi over 3 and 7 pi over 6. So 2 pi over 3 plus 7 pi over 6 is equal to, well, we're going to get a common denominator of 6. And so that's going to be what, 4 pi, and then that's going to be 7 pi, and that's going to be 11 pi over 6, and then 11 pi over 6 times a half, is equal to 11 pi over 12. And so this is going to be 11 pi over 12. All right. I know that doesn't quite look like a 12, does it? We'll erase it and write it again. All right. So remember, the sine function starts out at 0, and then it goes to its maximum, back to 0, then its minimum, and then back to 0. And so let's see how good I can draw this. I'm on a Wacom tablet. I don't use this thing very much. All right, and there's my graph. So we're going to have to plug points in the graph. So we've got the point pi over 6, 0. That's this first point here. And then we've got the point 5 pi over 12, 1. And then we've got 2 pi over 3, 0. And then we've got 11 pi over 12, negative 1. That's this point right here. And then we've got the point 7 pi over 6, 0. And so what we've got to do now is plug these in. So you come over here to ALEKS and you see the little coordinate system here. You click that and we're going to enter in a point. So we've got fraction, and then we've got pi over 6, 0, and we're going to plot that point. Okay, and you can see it puts like a little star there. I know it's faded, but if you close this, you can see it a little better, that little star there. Whoops. All right, and then we put in our next point, fraction, so that's going to be 5 pi over 12 and 1. And I haven't hit plot point yet, but you can see how it goes ahead and it puts the point there, and we put plot. And then the next one, we've got 2 pi over 3, 0, plot point. And then the next one, we've got 11 pi over 12, negative 1, and we'll plot that point. And then we've got 7 pi over 6, 0, plot the point. Okay, so we've plotted all of our points. You see that? And then you just come up here and hit graph function, and there it is, and it draws it in for you. Okay, but like I said, and you can see it looks just like the one we have over here. But like I said, work it out just like I did over here, the graph part, and then transfer everything. It gives you good practice. And then I'll come over here and recheck. Just like I said last time, I just forgot to divide by the 2 up here when I was solving that inequality. I don't know, my mind drifted off, I guess. But anyway, that's it right there. And that's how you graph trig functions in ALEKS. So it's not too bad. It works good. It works good. The only thing it makes you do is you just don't really have to draw this, but you've got to do all the important stuff, getting the point coordinates. So I hope that helped. If you have any, I was fixing to ask if you had any questions. Felt like I was thinking I was in class. But yeah, I hope this helped. I hope you enjoyed it. Hope you learned something. Check out my other videos. Give me a like, share, subscribe, comment, and I'll see y'all in the next one. Later.